My name is Ahmed, and I'm talking to you today about my thesis entitled Upgrading BIM Processes in Structural Design Office. Sorry. Yeah. Okay. The main problem we faced is that the most previous papers and literature reviews focus only on the theoretical relation between BIM and the structural engineering. A few papers have a discussion from practical view. So this work intends to provide a practical view for upgrading the work process in a structural design office to deal with the new build challenges. So the main objective of this work is to focus on the diagnosis of the current workflow of BIM in a structural design office and upgrade it from practical view to increase the work productivity, increase the work quality, save more time, and achieve the desired BIM use. This work was developed with Newton Structural Design Office. We started by diagnosing the existing workflow on weekly meeting and have discussions about the development of their processes to achieve the desired BIM uses, which is setting up the model for structural analysis, extracting quantitative of, and generate drawing from the 3D model. And we agreed that we will develop our work through four aspects. First one is updating the used BIM template with its components and creating a new database for the used object families and update the technical guide manual for structural modeling. Also, at the end, we will automate some tasks by creating new scripts to increase the work productivity and decrease the time waste. Newton customized its own template using Revit Autodesk software for many years. The main goal is to upgrade the used template and its contents to be suitable for different clients' requirements without decreasing the productivity. So the study was developed to apply NBS, which is National BIM specification, on the used template with its object, starting from naming convention for all objects, views, sheets, and everything related to the template. Before applying NBS standards on Newton template, the template contents were stored in Portuguese language. Then we translated it into English to follow NBS and be open more at all European market. In this table is just example about the old naming families and the modified or the new naming families we applied on Newton families. Also, sorry. For the template customization, the main goal of template customization here is to enhance modeling productivity. So some feature in the template has been updated and some has no change that satisfies the company needs. We started from the template general settings, which include browser organization. The views has been organized differently to serve Newton BIM users with translating Portuguese expressions and applying NBS mini convention on them. Also, new project parameters has been developed and added to the project information system family, such as model name, number, designer, and checker. Also, a splash screen has been updated as a view template to include Newton logo, project photo, and information about the model and the project. For the title block, after discussion, we decide to remain or keep the title block as it is because it was better for Portuguese market and the client requirements. So we didn't modify the title block. Also, new view templates were created with revision for the old one. Also, new filters were developed by defining the desired rules, such as filters for columns, beams, walls, also filters for rebars, wider diameters. Also, new phases were created by create different combination to control basis visibility, also color coding, and the exporting setting of IFC are modified too according to the desired MPT. We used here the IFC for design transfer view as a default. For the object library, this study has developed to apply the Uniclass and Omniclass classification system in the Newton internal object library. Firstly, with the collaboration with the Newton team, all the families have been collected, identified, and classified according to the elements structural usage. Then the work is implemented to the used elements by creating a new shared parameters for classification and NBS specification. Those shared parameters are stored in external text file, so the user can insert it to the project file. Also, they are stored inside the BIM template. The classification shared parameter were added as a type, not an instance, to apply classification on all families, family element. Also, all parameters were added under data group with read-only value, not to be modified by the user. In addition, we have product elements. Some structural elements are products, like steel sections and the precast concrete elements, which have their specification from producer and could be classified as a product, while other elements are not considered products, such as cast in situ elements, which cast inside under supervision without pre-ordering from a producer. So we classified some structural element as a product, and the other cannot be classified as a product. So some elements have no classification value for the Uniclass product number and description parameter as shown in this figure. Also, as a part of developing the object library, this study has developed to apply the exposure class to all Newton RC structure families. The European standard categorized the concrete exposure class to 6 categories. In this study, new shared parameter is developed as an instance, not type parameter. From a structural view, the instance parameter is more accurate because the exposure class has that depends on the element's location in the building, not its type. For example, a column located inside the building with no risk of corrosion has different exposure class from a column located at the facade of the building with a corrosion effect. Also, in addition, we a new shared parameters for IFC classification for all Newton families were applied, which added under the IFC parameter group to be exported correctly as a to IFC format. The IFC is stored in Newton database according to IFC4. The second aspect of our upgrading the work was creating a database for all Newton used families with classification systems naming convention. This data base has been saved in 2 different ways. The first one inside the template, and the other one was by creating Excel spreadsheet for all Newton families. The Excel sheet is composed of several columns and rows. The rows contains the used Newton families under main categories, such as structural column, framing, and floors. Each category contains all the elements types. By picking on it, open a new rows with all family types. While columns contains old naming, new naming, classification values according to Uniclass and Omniclass, also the default IFC classes value. Our third main goal is creating technical guide manual. This section aims to create a guide manual for the user to create to model the structural elements step by step in Revit software. After modeling, the guide manual has a model quality check that allow user to make self-audit after creating the model before issuing the model for the project collaboration. Our last aspect was automate some Newton tasks. So we developed a new Dynamo script to create Dynamo scripts to facilitate the work. The first one is to model the form work and extracting its quantity of. I will not go deeply through the script, but the main idea is to create the 3D model in a separate file. We create a template for the form work, and by running the Dynamo script inside this file, it creates. We have a template for the form work. This template contains the specific parameters that will read from the concrete model the area needed to calculate the quantity of the form work. Also create adaptive components families that will match with the surface area from the concrete model and create the 3D model for form work inside it. This Dynamo script has good performance in regular structural element, but has some problems in irregular and non-structural elements. So we create another Dynamo script that allow users by picking on each surface to create a surface with identified material with thickness and in a stored shared parameter gives the area of this element. So we have now area for the form work area for all the elements for irregular and the non-structural and non-structural elements.
So Ali, you have to finish. You have surpassed 1 minute already. So please be quick.
Here's my last slide. Yeah, the other script was creating footing insulation model and creating and extracting the quantity of. But the difference between the main idea of the footing insulation and the form work script is that at the same project file, we create footing insulation inside the file. The form work script, we create the 3D model for the form work at external file from the concrete model. So our conclusion at the end, we developed as a BIM template customization, updating the naming convention, just the general setting, object library, and we created a new template parameters. We create a new database. We create a modeling technical manual for all the structural elements. Also automate some tasks like form work and footing insulation. Thank you.